All right, so percent composition is what we're going to do today. Empirical molecular formula, we'll do that on Monday. So if you remember from beginning of the year, and I told you it wasn't going away, molar mass is where you get the masses off of the periodic table, and you add them together, and that's how you get the molar mass of the compound. Does anybody remember when we're using molar mass, how many decimal places we always put our answer into? 2, yes, thank you, thank you, thank you. So let's do these examples. I don't know that I left myself very much room, so we're going to try to do them up here. We'll do the first one. You should have a little bit of room there. So the first one is the ammonium sulfate that we're going to do right here, and then we'll do copper 2 chloride. Okay, so I'm going to put another screen on there so I have more room. Okay, you should probably, today, for right now, just go along with me. But you're going to definitely need a calculator today, and I forgot to put that up that you're going to need a calculator. All right, so the first one I said was ammonium sulfate that we're going to do, and that is NH4, 2 of them, because ammonium's a +1, and sulfate's a -2. So we're going to find the molar mass of this. So remember this 2 right here goes for everything inside, so that means you have 2 nitrogen, but you have 8 hydrogen because you multiply those subscripts, okay? And then we have 1 sulfur, and then we have 4 oxygen. So if we look up the molar mass for nitrogen, it's 14.01. We're going to multiply that by 2. We'll add 8, multiply by 1.01, because that's the mass for hydrogen. And then sulfur is, somebody look up sulfur, so you can get used to looking at them. 32.07 is what it would round to. Remember, we round to 2 decimal places. And then 4 times oxygen is 16. Okay? Get rid of these lines. So when I add all that up together, I do not have my calculator with me. Here it is. Okay? So 1401 plus 8 times 1.01 plus 32.07 plus 4 times 16. So we get our molar mass is 132.1. What is going on? 0.17. And anybody remember the units for molar mass? Huh? That's half of it. Grams per mole. Thanks, Russell.
You're so smart.
Russell is so smart. So grams per mole, okay? And that's going to be important because we can use those as conversion factors. So does that ring a bell? Okay? Does that seem familiar from when we did it last time? So we're still learning, today we're reviewing pieces of the puzzle. We're still learning pieces of the puzzle as we get towards stoichiometry, okay? All right. So the other two, I think, what was the other example? I don't think. Let's go back. Okay. So copper 2 chloride, we can actually do that one right here on the screen because it's short. Copper 2 chloride, remember that 2 is saying that we have a +2 for copper. Chloride's a -1, so our formula would be CuCl2. So copper is 63.55 plus 2 times 35.45 is equal, I'm going to add that up, that's chlorine. And I get 134.45 grams per mole. Okay? It's going to be important for you to always use 2 places on your molar mass. Okay? Especially as we're going through during my absence and we're doing some Canvas worksheets, because when I'm putting those numbers in, I have to put them in as exact numbers. So you have to round to 2 places. Okay? If you're still struggling with rounding, you might want to spend some time practicing that. Okay? So that's how you do molar mass. You do have some practice problems on the next page of your notes for left side, so make sure you do those before the test. So now let's talk about percent composition, okay? And the funny thing about chemistry, when we do math and chemistry, is these are things you know how to do outside of chemistry, but we put a chemistry word with it, and all of a sudden you think you don't know how to do it. If I want to find the percentage of anything, how do I do that? I add everything up, and then I divide part by whole, right? Part divided by whole times 100, okay? It is the same thing when I say percent composition. I'm finding the percent composition of a compound, okay? So, like say I'm doing sodium chloride, I just want to know what percentage of that compound is sodium by mass and what percentage is chlorine. So still, I'm going to do part over whole. So if I'm doing this for a compound, what do you think the whole is? I'll give you a hint, we just calculated it. What did we just calculate a while ago? Molar mass. So the molar mass is the whole. Okay, so that's what you're going to be dividing by, the molar mass of the compound. Okay, so it's actually fairly simple. You'll like it. So first thing you have to be able to do is write the correct formula. Second thing you're going to do is you're going to find the molar mass, and then you're going to divide each element by that molar mass. It's a percentage, so we multiply by 100, and it says we're going to actually do this in 1 today for our worksheet. So you're going to report the percent in 1 decimal place. So I think it says 2 in your notes, so go ahead and change that to 1. Okay, molar mass is always in 2 decimal places, but we're going to put our percentage in 1 decimal place. Okay, so let's do some problems. Okay, so we are going to practice with finding it for zinc carbonate. Okay, you can, I don't know where number 4 came on. I don't have that. That's not in your notes, is it?
No, it isn't.
Okay. Yeah, it's not in your notes. All right, so we're going to do the zinc carbonate and ammonium nitrate. Okay, so we'll do some practice problems. So,
This isn't in the notes.
no, these are, but you see that there's a space that says various examples down below underneath the rules. Let's put that example here for you. Okay, I'd use different examples for each class period because I get bored. So I'm going to do zinc carbonate for y'all. Okay? All right. So the correct formula for zinc carbonate, zinc is a +2, carbonate's a -2, so it's just ZnCO3. Okay? So the first thing I'm going to have to do is figure out the molar mass. So MM is going to be short for molar mass. Zinc is 65.39. Can y'all see the chart from here? I can't. Look up there.
65.39.
Okay, so zinc is 65.39 plus carbon is 12.01 plus oxygen is 16. So we'll add 3 times 16. So our molar mass, 65.39 plus is 125.40. Does anyone have a calculator handy so y'all can check my math? Make sure I'm doing it correctly. Okay, that's grams per mole. So to figure out the percentage of zinc, I'm going to take the mass of zinc, which was 65.39, and I'm going to divide it by 125.40 times 100. Was that correct? Thank you. I always need someone to check me. So this is going to be 52.1%.
Yep.
The percentage for carbon is 12.01 divided by the total mass, because it's part over whole, times 100.
9%.
Would that round to 9.6?
Yes.
So 9.6. Again, when you enter the answers into Canvas, you're going to be really need careful to make sure you round correctly. Okay? And then lastly is the percentage of oxygen. I always put OX because if I put just O, sometimes people think it's a 0. And so then we're going to do 3 times 16 because we have 3 oxygen divided by 125.40 times 100. And And I got 38.3.
Working
Is that what you got?
on it. 38.2%. Oh yeah, round up to 38.
So a way that we can check ourselves is add up the percentages and see if they add up to 100. Or really, really close to 100. And I get 100%. So I must have done it right. Okay? So not too hard, right? It's pretty easy. Okay? So the worksheet that you have two worksheets today. You have the one that's the percent composition, and we'll talk about that one in a second. That one's going to be due in Canvas. The other worksheet is practicing molar mass, because molar mass is going to be so important for the rest of the year. So I want you to practice it. Okay? And then the back part is, do you remember the conversions of grams to moles, moles to grams? I didn't think so. So I'm gonna show you two examples of that. We're gonna use this zinc carbonate again, so we're gonna remember that molar mass right there. Okay? So let me show you how we're gonna do that. Okay. So we have that zinc carbonate, and we said it was 125.40 grams per mole. Okay? So we're going to do a grams to mole conversion first, so I can show you how to do that, or remember, we've already done it once. So someone make up a number and give it to me.
4.
For what? Give me some other numbers.
7,592.
I need a normal number.
45.
Thank you. Let's say I have 45 grams of zinc carbonate, and I want to know how many moles that would be. Okay? So I would say 45 grams of zinc carbonate. I want to get rid of grams, so where does it go? On the bottom. And then I want to go for 125.40 grams per 1 mole. And then my units cancel. And then I have a number on the top and a number on the bottom. So you remember what I do with that?
Divide it out.
Divide it out. Yes, see, y'all remember. And then I only have how many significant figures in that 45?
2.
2. So I want my answer in
2.
2. So that would round to 0.36 moles of zinc carbonate. And we can kind of ask ourselves, does that number make sense? And it does, because 45 grams is much, much less than what 1 mole is equal to, which 1 mole is equal to that 125. Okay? All right, now let's go the opposite direction. Okay, so let's just erase all this. Same molar mass. This time we're going to go moles to grams. So someone give me an answer, a number for moles. And don't give me 0.36. We're not going to just go backwards.
2.5.
2.5. Okay. So this time we have 2.5. I'm going to add a 0 on there. 2.50 moles of zinc carbonate. And I want to know how many grams would that be. So I start with the 2.50 moles. I want to get rid of moles, so it goes on the bottom. So 1 mole on the bottom, and then the molar mass on the top. Now I have both numbers on top. It's a 1 on the bottom, so I just need to do what? Multiply.
And there's only 3 significant.
There is 3. I put that 0 on there to see if I could trick you, and I couldn't. Good job. So I need 3 significant figures in my answer, so it would be 314. I'm going to write down it would be 3.3.5. I said point too many times, didn't I? It's 313.5. So in 3 significant figures, that would round to 314 grams of zinc carbonate. Is that ringing a bell?
Yes.
Heck yeah.
Then I'm very happy. So that's where we're going to stop today.